Hi, Miss Marion here. We're going to go ahead and do Unit 5, Lesson 1 and Lesson 2 today. So underneath the modules, there's Canvas pages for both of them, but we're kind of combining it together for today. So that's why there's a lot of stuff in the modules. But just kind of keep that in mind. So today, turn back to page 185. That's where we can find the ICAT statements for Lesson 1. I can write rules when I know input and output pairs, and I know how an input-output diagram represents a rule. So go ahead and write your sentence and give yourself a number. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. All right, and as I said, we're doing Lesson 1 and Lesson 2. Still stay on page 185. Lesson 2 is, I know that a function is a rule with exactly one output for each allowable input. And I know that if a rule has exactly one output for each allowable input, then the output depends on the input. And we'll talk about all of this, but go ahead and write yourself a sentence on how you feel about those two. And then also give yourself a number again. So 1, I don't remember. 2, I kind of remember it. 3, I do remember it. And then 4, I can teach it to my friend. So our learning goals, or the things we'll be able to do after today for Lesson 1, describe orally how an input-output diagram represents a rule. Identify a rule that describes the relationship between input and output pairs, and explain orally a strategy used for figuring out the rule. The learning goals for Lesson 2 is we can comprehend the structure of a function as having one and only one output for each allowable input. We can describe orally and in writing a context using function language, as the output is a function of the input, or the output depends on the input. And then also identify rules that produce exactly one output for each allowable input and rules that do not. So these are everything that we're going to go ahead and accomplish for today in today's lesson. All right, go ahead and turn to page 7. On page 7, it says study the statements carefully. 12 divided by 3 is 4 because 12 equals 4 times 3. And then 6 divided by 0 is something because 6 equals x times 0. What value can be used in place of x to create a true statement? Explain your reasoning. So go ahead and pause for a second, answer that question, and then come back to me. All right, so let's kind of talk about it. What variable what letter can we put in for x for the variable x to make this statement true? And honestly, there is none. So it's because of the multiplying by 0. Can I multiply anything by 0 to make it 6? And unfortunately, there's nothing that will make that true. So it's more of just kind of getting our minds thinking about different things and knowing how things work and don't work. But again, we can't multiply anything number. We can't take 0, multiply by number, and get 6 as the final answer. Okay? So before we go into today's lesson, this is lesson 1 that we're kind of dealing with right now. We need to remember that a rule can be anything that allows or produces an output for a given input. So these are kind of the rules. So think mathematically. If we have an input, we do something with it, and then we get an output. So kind of keep that in mind as far as what we're going to go ahead and do in our next thing. So this is kind of a diagram as far as what I was just really talking about. We have an input, and then we have this kind of function box is what we're going to call it. And there's some type of rule that's going to happen, and then we'll go ahead and get an output. So kind of keep this in mind, this visual representation. And we're going to actually be using this today to go ahead and answer some questions. So again, to kind of help us out, introduction, this is not in your workbook, but just kind of think about it so we understand and know what we're looking for. Notice how I have, it says for the input-output rule, fill in the table with the outputs that go with the point. Okay, and so I have a table. And honestly, technically, the input-output, we can kind of think of it as like an x-y table. We've been doing this for a while. So I have an input, which is also our x. We're going to put it into something that happens, and then we're going to get an output, which is our y. So our rule, as you know, I have this visual representation over here, as here is our kind of a rule box, remember? And then our rule is going to be multiply by 2. So really, what is it asking? So if we do 3 over 2, we're going to say 3 over 2. We're going to multiply that by 2. grab your calculator, do it with us. We're going to say 3 over 2 times 2, and our answer is going to be 3. So then our output would be 3. Let's try the next one. So our rule is to go ahead and take the number. Again, we're going to multiply by 2. 2 times 2 is 4. And then let's do it one more time. Our input is 5 over 2. So we're going to say 5 over 2 times 2. What is our answer? That is 5. So kind of keep this all in mind as far as what we're talking about as far as these function kind of diagrams, and what we're doing as far as input and then also output. All right, on page 8, here is number 1. We have 3/4, and then we're going to add 1, then multiply by 4. And so we have 3/4 we're going to put in there, and then 2.35, and then 42. And then also, you can also put extra numbers, your choice, down here. And then also, so you do your input, and then we're also going to do the output. So we're going to go ahead and do the 3/4. So they had 3/4. Their final output number is 7. So let's actually do what it asks us to do. So we're going to say 3/4, add 1. Okay, so we're going to say 3/4 plus 1 is 1 3/4. And then we're going to take this and we're going to multiply it. So then we're going to do 1 3/4. We're going to multiply it by 4. And then our final answer is going to be 7. So we do have to do like order of operations when we're doing this as far as following them through. So go ahead and try 2.35 and 42. So put those numbers in. So pause and put those numbers in, and then come back to me. All right, so let's try 2.35. So we're going to say 2.35. We're going to add 1, which is 3.35. And then we're going to take the 3.35 and we're going to multiply it by 4. And our answer is 13.4. Then let's go ahead and let's try 42. We say 42 plus 1 is 43. Then we're going to take the 43 and we're going to multiply it by 4. And our answer is 172. So I'm not going to fill in the last 2 boxes of the table because I don't know what numbers you did. So I'm going to go ahead and go on to number 2. All right, let's go ahead and look at number 2. Again, so here on number 2, we have 3/4. It says name the digit in the 10th place. And they have 3/4 as the number going in. So let's think about that. So we have 3/4. So if we take 3/4 and we do 3 divided by 4, our answer on that, so 3 actually physically divided by 4 is 0.75. Remember, the first position is what is considered the 10th position. So that's why the answer is 7. So go ahead and pause, answer the 2.35 and the 42. So pause and then come back to me. So again, we're looking for the 10th position. So 2.35, our 10th position is 3. Let's look at 42. So 42 is a whole number, but we can also write it as 42.0. So what is in the 10th position? 0. And then the last 2 parts of this table, I don't know which numbers you did, so I'm not going to go ahead and go over this. I'm going to go ahead and go to number 3. All right, here is number 3. So number 3, they do have the 3/4. The rule is to write 7. So if okay, so it's like if I have the number 3/4, they want us to write 7. So go ahead and do the 2.35 and the 42, pause, and then come back to me. So again, if they have the 2.35, no matter what number I have, they want me to go ahead and write 7. If I have 42, they want me to write 7. So this is our rule. And again, the bottom two, I don't know what numbers you did, so we're going to go ahead and move on to number 4. All right, so let's talk about number 4 before we actually go ahead and do it. So here's number 4. We have this X number. So they say the input is X. It says divide 1 by the input, and then the answer will be 1 over X. So remember how we kind of talked about the tables before as far as the input and output. So the X is our input, and then the 1 over X is our output, or that Y. So on our table, it's kind of X comma Y. So if we have it where we have 3 over 7 is our number. So they're telling us to go ahead and do 1 divided by 3 over 7 and put 3 over 7 as a fraction. We stick it in our calculator, and you can get 2 and 1/3, but 2 and 1/3 is also 7 over 3. So that's why they have 7 over 3 as the output. So go ahead and put those in your calculator and see what you're going to get. So pause, do that, and then come back to me. All right, now since you've done it, so we're putting in 1, and then we're going to do 1 over, and then our input was 1, so it's 1 over 1. And then for the 0, our input, or X, was 0, and they tell us to go 1 over 0. And if we actually do 1 divided by 0, it actually, there's an error. So it has technically no output. Okay, and then the bottom one, you can do your own. I'm going to go ahead and skip this because I don't know what your number you did. So we're going to go ahead and move on. All right, so let's kind of talk about different things where we can show if there's an input and an output, and then also like the function diagram. So as an example, a person is 60 inches tall. Do you know their height in feet? So just kind of to help us out, I'm going to do a diagram. So we're going to put in inches, and we want to bring out the feet, right? So we know that there is 12 inches for 1 foot. So how do we go ahead and do that? How do we get the final answer? We are going to take our input, we're going to take our inches, and we're going to divide it by 12, right, to kind of make it the amount of feet. So this is going to be divide by 12. So if we have that our input is 60 inches, we take that and we are going to divide it by 12. So then 60 inches is 5 feet. So this is going to go ahead and help us with kind of the next couple of things, the next activity that we're going to go ahead and do. So here is our diagram that I went ahead and drew. Okay, and then again, this is going to help us with our next activity. So in this activity on page 16, it says say yes or no for each question. If yes, draw an input-output diagram, kind of like we did with the 60 inches for how many feet. And if no, give examples of 2 different outputs that are possible for the same input. So number 1 is a person is 5 feet tall. Do you know their height in inches? So go ahead and pause. So go ahead and answer that. So pause and answer that, and then come back to me. All right, so let's go ahead and let's make our table, our function box, right? So we're going to go ahead and put it in. We're also going to bring something out. So we have the 5.5. And then how did we find out how tall it is in inches? We are going to multiply by 12. So let's do 5.5 times 12 is 66. And then it will be inches. All right, number 2, a number is 5. Do you know its square? So go ahead and pause and answer that, and then come back to me. So again, we're going to go ahead and do our box. So we're going to take the number and multiply by itself. 3 are going to put in 5, and then 5 times 5 is 25. All right, number 3. The square of a number is 16. Do you know the number? So go ahead and pause, and then answer it, and then come back to me. So this one is no. And the reason why is because what we're doing is we're trying to figure out what number multiplied by itself would make 16. We know 4 times 4 equals 16. But this one actually has 2 answers. We can do -4 times -4 equals a positive 16 also. So this one is no. It's not just going to have one input to one output. It actually has, for the input, it actually has 2 outputs. All right, a square has a perimeter of 12. Do you know its area? Go ahead, pause, answer it, and then come back to me. So yes, this actually has one input and one output. So if we think about it, we can do our box, right? And what do we know about a square? The square has all the sides are the same. So we need to find the side length and square it. Okay, so first of all, we had to figure out the side length, right? So side length, then square it. I guess you can kind of say it that way. Sorry, it looks so messy. I don't have my pen today. Sorry. So if we think about it, we have a square. So I'm going to change my color for a second. I'm actually going to draw this. So we know we have side, 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 and side. All of this added together is going to equal 12. So if we think about it, so what number, if we add together that same number 4 times, what would that be? So that number, our side length, would actually be 3. So let's think about it. 3 plus 3 is 9, plus 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So this works. So then we're going to take the 3, and we're going to multiply it by itself, and then our answer would be 9. So technically, actually, the number that we're putting in is 12. And then we get back 9. All right, number 5, a rectangle has an area of 16 centimeters squared. Do you know its length? So go ahead and answer that question, pause and answer it, and then come back to me. All right, let's think about rectangles. This answer is no, but let's also think about rectangles. So rectangle is always like our length multiplied by our width. And so there's many different ways we can actually do our length multiplied by our width. We can do 2 times 8, and we get 16, right? We can also do 1 times 16 and also get 16, right? So there's different ways we can actually kind of get this as far as the rectangle. We wouldn't do 4 times 4 because that would actually technically be a square. And we're actually talking about rectangles where lengths and the widths are different. So here are 2 answers. So our input is the rectangle of an area of 16, but we can actually get 2 outputs. So this actually doesn't work. All right, number 6, you're given a number. Then do you know the number that is 1/5 as big? Okay, so go ahead, pause, answer that, and then come back to me. So technically this answer is yes. Let's actually draw that function box, right? So we have our input, and our input is just input. We don't know what the input is, but we know we're going to put something into it, and we're going to multiply by 1/5. And then what do we have? We have 1/5 times the input, right? So are we only going to get one answer with one input? Yeah, because if we took that number, we multiply by 1/5, you can only get one number back. So this answer does work. It's a little bit different. We don't have a distinct answer to give you, but it still has one input with one output. All right, number 7, you're given a number. Do you know its reciprocal? So remember what reciprocal is. That's kind of the flip of it, okay? So think about this. So pause, answer it, and then come back to me. So does this one work? Yes, it does. Why does it work? It's kind of like number 6 in a way. So we have this input. We're going to put in x, and we're going to divide 1 by the input. And then our answer is like 1 over x. But I'm going to erase what I put down. So we're going to divide 1 by the input. Okay, that's what we're doing. And then what do we get out? We get 1 over x. So if I put a number in for x, then I'm going to get 1 over x back. So 1 input with exactly 1 output. So on page 18, we have a glossary term. And we've been talking about a function. A function is a rule that assigns each allowable input exactly 1 output. So, okay, what does that really mean? There's 1 input. So if I have 1 input, I have 1 output. That is what is considered a function. So it's kind of like what we've been doing. We're just putting a fancy name to it. Again, so a function is where we have 1 input, has exactly only 1 output. So go ahead and write down your definition on page 18 for function. All right, so kind of bringing everything together. We did lesson 1 and lesson 2 today. So we have our inputs. Our inputs is what we're putting into like a function, into that function box. What is our output? That is what we come back out, right? And then remember, function is 1 input with only exactly 1 output. So this is kind of everything that we've been talking about today. And so understanding these different things, this whole unit is going to actually be on functions and kind of what they actually mean. So go ahead, and we're doing both practice problems. So if you see in Canvas, you have 2 Canvas pages. All the information's on there. We're also doing 2 practice problems. So make sure you go ahead and get those practice problems done. And that is our homework for today. Have a good day. Bye.